Hello everyone. In this video, I'm going to demonstrate how to generate sinusoidal signals using Matlab. Let's say we want to generate two sinusoidal signals having the same frequency, same phase, but different amplitude. So how do we generate that using the Matlab? We'll learn in this video. So before we do the Matlab simulation to generate the signals, let's first try to understand the mathematical representation of a sine wave. So a signal or a sine wave that is a function of time can be represented mathematically as shown in this equation. So a signal st, it is represented as a sine 2 pi ft plus phi, where a is the peak amplitude or the maximum strength of the signal, and then the maximum amplitude or the peak amplitude of the signal is represented in volts. Its unit is volts. And f is the frequency of the signal, which is the rate of change of the signal, and its unit is hertz. So this frequency is reciprocal to the period of the signal or the time period of the signal. So t is inversely proportional to the frequency. So this repetition or the time period means like the complete the time taken to complete the one wave of the signal. All right, and omega is the angular frequency, which is equals to 2 pi f, and this phi, it is the phase of the signal which gives the relative position in time, and its unit is radians. So with this background knowledge, let's start generating the signal. So to generate the signal, first let's define the time t. Let's start from 0 second to 5 seconds, and we want it to be at an interval of 0.01, let's say, and it should be colon in here. This semicolon represents the end of the command given in this line. So here it is. And let's now define the axis. So axis axis is, we can define it like here. So we define it from 0 to 5 seconds, and then minus 5 to 5. So what does this mean? So here we are defining the x-axis from 0 to 5 and y-axis from minus 5 to 5. So when we press enter, it generates the graph like this, figure like this, right? So in here we can see like the time is from 0 to 5 seconds in the x-axis, and then in the y-axis from minus 5 to 5. This will represent the magnitude or the amplitude value. So now we want to generate the graph, so we will use the function called plot, right? So we define it in time. So how we want that graph to be? So we want to define the signal st. So let's say like its amplitude is 1, and 1 times sine. So here like we are referring to this equation, sine 2 times pi times f, let's say like it is 1 times t, right? And then let's say like the phase is 0, right? And we want the graph to be plotted in blue color, and then we press semicolon. So when we complete this function, a sinusoidal wave is generated. So this signal, it has the maximum amplitude of 1 and then the frequency of 1, which means one complete waveform, it takes 1 second. All right, so that is the frequency. So now let's say like we want to generate the another signal having a different amplitude value. So to do that in MATLAB, it's quite easy. We can just press the upper arrow to go to the previously entered functions or the commands. So when I press the upper arrow, like it will take me to the previously used commands. So here we can change the amplitude from 1 to let's say like 3, and then let's change the color to be from blue to green in color. So when we press enter, we can see that the signal generated is now is in green color and has the amplitude of 3 and then frequency 1. But here is only one signal, and then the previously generated signal is not available anymore. So if to have two signals in the same figure, if we want to have that way, then we use the command hold on. All right. And then we can refer back to the previously used command. So if we press enter now, it will generate the signal in the blue color as well. Now we can see both the signals in the same graph. So here, signal in the blue color, it has the amplitude of 1, while the signal in the green color, it has the amplitude of 3. So this way we can generate two sinusoidal waves having the same frequency and same phase but different amplitude values. So let's say we want to generate different graph which have like the same amplitude and same phase but different frequencies. So how do we do that? So it is quite simple. So for that we can just refer back to the same commands that we used earlier, and then create the axis as well, and then we take mm, one of the signals like this. Now we want to change the frequency. So for that, what do? We use the whole line because we want to have both the graphs in the same figure. Now we want to change the frequency. So here instead of 1, let's say like we will change it to be 2, and then now this time we want the color to be in red. So when we press enter, there are two signals generated, one in the blue and the other in the red. So the one in the blue, it has the frequency of 1, because one complete waveform, it takes 1 second for the blue. However, for the red, there are two complete waveforms within the duration of 1 second, right? So that's why the frequency is 2. So this way we can generate two signals, two sinusoidal waves having the same amplitude and same phase but different frequencies using MATLAB. Also, we can have signals with different phases as well. For that, let's again define the time and then the axis. And then let's take one of the signals. Let's say like the first signal, it has the uh, 0 phase. Now we want to have two signals in the same. So we use the hold on function. And then now we want to define another signal having the same amplitude, same frequency, but different phase. Let's say like the phase is 90°. Then let's say like this is in the green color. And then when we press enter, we can see that there are two figures, right? One in the green and another in the blue, two sinusoidal waves. Here, the green is starting before the blue. For example, if you look at this, see like the green already started at this point, but the blue is after certain time. It started only at 1, right? But the green already started before 1. So this means like the green signal, it is ahead of the blue signal, which means blue signal lags behind the green signal or the green wave. And then the difference is the phase difference, which is 90, all right, or pi by 4. Pi, it means 180, and then 2 pi, it means 360, all right? Sorry, pi means 180, so this 90, it is going to be pi by 2, all right? So this way we can generate signals having different phase as well. Now, if we want to look at the combination of all of these, let's say like we generate a signal like this, and then now we do the hold on, and then we generate different signal having the different amplitude. Let's say like its amplitude is 3, and then 2 pi f, let's say like the frequency is 2, and then has the phase of, let's say like pi by 4, right? And let it be in the color red. So this way we can have different color of the signal. All right, so this way we can generate two different signals that are differing in the amplitude, frequency, and phase. So using Matlab, it is quite easy to generate the signals of different amplitude, frequency, and phase. So which I have demonstrated in this video. I hope you guys enjoyed the video. Thank you for watching.